Hello, this free response question is majorly about the Unit 2 dynamics, and you see the system of masses and pulley. And in this diagram, well, this pulley will rotate also, but we will not consider its rotational motion. And they are mentioning here the block 1 and 2 move with constant velocity down the inclined plane, as well as the surface of this incline is rough, which means that the M1 and M2 will experience frictional forces, which are also mentioned here. Okay, so in the first question, we have to draw and label all the forces on block M1. Well, first, if we quickly go through all the forces in the system, right? So it is good that this is the force of tension, and the same is the force of tension in this direction because both are attached with the same string. And secondly, there is another force of tension in this string. There will be one force of friction, and this is another force of friction. So that is 2F. Don't you think this have weight mg? Whereas this is the force of tension. Okay. And don't forget about the normal forces exerted on M1 and M2. Okay, so these are all the forces exerted and plus the weights of these blocks. Okay, now for the first question, draw and label all the forces on block M1. So students, as you see, they say that it is moving with constant velocity, right? So if we see in this diagram that the weight that is always exerted vertically downward, so that is the one force M1G. Whereas it is attached with a string, that's why this is a direction of force of tension. Let's call it T. Okay, as it is moving down on the incline, that's why frictional force that will oppose its motion must be in this direction, and this frictional force is F, right? The fourth force that is exerted on M1 is actually applied by the surface of incline that is perpendicular to the surface of incline. So this is the normal force, let's say N1. Okay, now let's move to the next question in which they say express your answer in terms of these variables. So first question is determine the coefficient of kinetic friction. So as the object is moving, so that's why it is experiencing kinetic friction between the inclined plane at block 1. Okay, now we will find out the coefficient of the kinetic friction, but for this we need an equation, and we will get that equation from the Newton laws of motion because it is moving, so it either it's accelerating or non-accelerating. In both cases you will get an equation. So students, we know that the weight is always vertically downward, and this is our x-axis positive, right? And in the same manner this is the y-axis. So if you make the components of the mg, if we break down this vector into its components, so we will see that the one component will be along the y-axis, that is equals to m1g cos theta, as this is angle theta. And is not this equals to the normal force? So this is a normal force n1. So we can say the normal force n1 is equals to m1g cos of theta, right? And the other component will be equals to m1g sine theta. Okay, and that is equal to the forces which are in the opposite direction. Okay, so right now we are only concerned about this. Okay, so in the first question they are asking, in the second question B, part B, they are asking about the coefficient of kinetic friction. So we know that it is experiencing the frictional force, this one, right? And that is always equals to mu normal force, that is n1. So what will be the value of mu? That should be equals to F over m1g cos of theta. So this is the desired expression because they said that your answer must be in terms of these variables. Okay, now in the next question they are saying determine the value of suspended mass, capital M, that allows the block 1 and 2 move with a constant velocity. Okay, so when they say constant velocity, so system is, if the system is moving with a constant velocity, which means that sum of all forces of system is 0. All the forces are balancing each other, and which means that there's a no acceleration. So if there's a no acceleration, it means that, you remember I had shown you the forces in this diagram, and I told you that this is the one force mg. It means that it must be equals to the upward force, that is a force of tension, right? Let's say T prime, because there are the two strings. Okay, so this is also the same tension in magnitude. Okay, so students, to find this larger mass, let's make the set of equations, because let's start from this. We know the mg is equals to this tension, right? So this is our first equation. So mg is equals to T prime, right? Now this is the same force at this end, that is T prime. Okay, whereas you know that there is also another force, that is 2F. Clear? That's the force of friction. And what about this force that is exerted due to this string? So this is T. So if the m1 is moving at a constant velocity, so which means that the forces on x-axis must be balancing each other, right? And should I add, don't you think, should I add this force a component of the weight, m2g sine theta? In fact, I had already shown you how do we make the components, so that's why I have written directly. So can I say for the mass m2, if on the right side, on the positive x direction, the sum of T prime plus 2F is equals to the force is T plus m2g sine theta. Now once again we have one another unknown, that is tension T. Okay, so to find the value of tension T, we need another equation. So let's come for the mass m1. Okay, for m1 we know the one force of the tension is this, that is T. The one is a force of friction F, whereas this is a component of the weight. Okay, so it means that we can say the tension T plus force of friction must be equals to m1g sine theta, because all of the masses are moving with constant velocity. So rightward force is equals to leftward force. Okay, now what we will do, students, we can plug the value of tension T here, and then we can plug the value of T prime here. Okay, and then you will find the larger mass. Okay, so this is our method 1, and then I will tell you the direct approach method. Okay, so the tension T in the second string is this one. So students, I am going to substitute its value here. So now what we will get, so T prime, the tension in a first string, I'm considering this is the first string. So T prime plus 2F is equals to m1g minus F plus m2g sine theta. Okay, now from here we can find the value of T prime. Okay, you can gather m1g sine theta plus m2g sine theta, whereas negative f, you can take the 2f on the other side, so it will become negative 2f, so that will become negative 3f. Okay, so now can we plug the value of the T prime in this equation to find the larger mass? Okay students, so the larger mass mg is equals to T prime, and that is, can I take the g sine theta common, so it will be g sine theta inside m1 plus m2 minus 3f, right? And in another step you can divide the g on the other side, so it will be like this. Okay, so if I further divide g, okay, well, like if I make a separate fractions, so it will be sine theta into m1 plus m2 minus 3F over G. So this is our final expression for the mass M. Okay, students, now let's talk about the direct approach. Can I say that this T prime and this T prime, they have a same magnitude? So they are nullifying each other, they are cancelling each other's effect. Okay. As well as the normal force and m2 cos theta is also balancing each other effect. And what about the tension in the string and this tension? Both have a same magnitude but at opposite of each other, so both are also cancelling out each other. So don't you think overall, if you cancel all of the forces which are balancing each other, right? Like the tensions, mainly the tensions T prime and T prime and the tension in the second string. So what you will get then? You will see that the m1g sign, and we know that the whole system is moving with a constant velocity. So we will see that actually the forces which are actually opposing each other, on a one side we will have a mg, the weight of the block, and this weight, which is a force, is countered by how many forces? Is countered by m1g sine theta, because m1g sine theta is trying to move the system down the incline, and this m is trying to move the system up on the incline. That's why I'm saying it is opposing. Okay, plus m2g sine theta, that is also countering mg. We cannot ignore the friction, right? Okay, and friction is trying to move the system up on the incline. Okay, this both friction, this one and this one, are trying to move the system up on the incline. That's why I must write here F as well as 2F. Clear? So on this side, I have written all the forces which are trying to move the system up, and these are the forces which are trying to move down, and that's why we can make equation from here, and that is exactly what I had shown with systematically with the help of equations. So that is, and students, you can take this 3F on the other side, so it will be negative 3F, and once again it will be the same result that we got here. Okay, so students, the last question, which says that if you cut the string, from the middle, okay, so what will happen? Now the block m1 will no more moving with the constant velocity, because now the forces will be unbalanced. Okay, that I have to show you how it will be unbalanced, and we have to find out the acceleration. So we can find out acceleration if you find the resultant force, the net force, and then we can divide that net force with mass to find out acceleration. So let me show you. Okay, students, now we are answering the last question, that is T. And if you cut a string, now the nature of the surface will not change. Okay, so it means that there is still the force of friction, that is F. And you remember we had made the component of the weight. So now m1g sine theta will dominate the frictional force. So that's why this object will accelerate in this direction. Okay, so this will be the direction of acceleration. Okay, students, and if we make an equation according to Newton's second law, that the sum of all forces is equals to m1a, then sum of all forces on x-axis, the larger force is m1g sine theta, right, its magnitude, minus the frictional force is equals to m1a. So in that case, the A will be equals to m1g sine theta minus F divided by m1. Okay, and you can further divide, so it will be g sine theta minus frictional force over m1, that is acceleration. Now if you make the equation according to your rectangular coordinate system, let's say you said that this is a positive x, then acceleration is negative. So now according to that, my equation must be equals to frictional force, that is positive, plus into negative mg sine theta, that is negative because it's directed on a negative x-axis, is equals to acceleration is also negative because that's also in the direction of negative axis. So students, it will once again give you the same thing. If you multiply on both sides with -1. So this is our final answer of the acceleration, and I hope you understand this whole FRQ solution. Thank you.